So today we are going to learn this recursion. Have any of you learned this before? Because some instructors they will teach recursion in 1046. No? Okay, then we will just learn it today. So uh, suppose you want to find some files under a directory. And this directory, it has some subdirectory, and the subdirectory has subdirectory, right? If you want to find it, usually, intuitively just find like a recursively, find the subdirectory and the subdirectory of that subdirectory. This kind of a repeated way. It's called recursive. This kind of behavior is like find something, do something recursively. And so recursion, this kind of process is just a way to, of course, we can just list all the directories and using a for loop to check every single file in those directories and to find the files, right? But if we use recursion, we can just, we don't have to list all the files. We can just, using this elegant way to make maybe just 2 or 3 lines to find all the files for us, instead just list all the files and do a for loop. So let's see an example. So we know this, like, okay. Okay, we know like factorials, right? 0 is 1 and n equals to n multiplied by n minus 1 all the way to 1. It's simple. Assuming someone lets you to compute the n factorial for him or for her, you can just using a for loop to multiply, for I from 1 to n. Yeah, that's of course that's doable. But of course, we also have this rule, like we know that the n factorial equals to n multiplied by n minus 1 factorial. So knowing all these things, we can actually solve this problem using recursion. So assuming the function, the method we compute this n is this factorial n, and we just need this if-else statement. So if n equals to 0, the result is 1. Else, return n multiply factorial. It's just a function, it calls itself. So this n multiplied by n factorial n minus 1 is actually a mimic of this third line, like this equation. So the key for recursion is just like, we need to figure out, because this one is a base statement, like in what kind of state, circumstances, this program should stop and return the results. And the other one is this function. Sometimes it's very difficult to figure out how to, how to solve a problem using a simple function. But as long as you know this function, it can be, the script can be done in an elegant way. You don't have to use a for loop. And this one looks much clear and much clean. So to compute this specific statement in Java, so the function, the Java compiler, they call this function, and it will just do it using that equation. So factorial 4 will be equals to 4 multiplied by factorial 3.
Here mentioned, is there a method, or
yes,
use like maths dot?
It's a method. It's a defined method.
Oh, defined.
Yeah. So because from the previous, the program will only return when n equals to 0. So if it's not 0, the program will just continue and minus 1, like factorial 3 equals to 3 minus multiply factorial 2, and factorial 2 equals to 2 multiplied by factorial 1, all the way to here. When it reaches this space statement, the program knows, oh, factorial 0 equals to 1. Then it can do the calculations for us. All the way back to do the calculations. So if we use a diagram to show it, it will be something like this. Just the program just do it recursively and all the way to factorial 0 once it knows this is 1. If you just return the results and do the calculation and all the way back, it's just like 1 multiplied by 2, 3, 4, all the way. Recursion is also very intuitive in the memory stack. Like, hi. Speak louder. Okay. So this is a memory stack. You might already have you ever seen it before? No. Okay. Like when a program is run in our computer, the computer uses the memory is like a stack. We will actually discuss stack later in this course because stack is a very popular data structure and very useful data structure. Basically, like is it like a elevator? Like the first person go into this elevator will stay at the very end of it, and it won't. And the second person go into here and go into here. And for example, there are 4 persons in this stack. This one n equals 4. It cannot leave this stack. It has to be like the first in, last out. So this one goes into the. I mean, this one is the last one going into the stack. So if I remove it, I can only remove the 1 as the top of the stack. So this kind of a way is like this kind of definition will make it easier for the program to understand like which statement it should be performed. For example, when this factorial 4 is pushed into the stack, I mean the program doesn't know how to compute it. It will go to factorial 3 and also factorial 2, 1, and all the way to 0. When it goes to 0, the program knows what the result is. It will return this result equal to 0, and the program will release this space. So this one will be removed. You can see now here, the one on the top is removed, and the remaining 4 is here as this one. And we can just compute this one and remove it. And there are 3 remaining, and compute this one, remove it, 2 remaining, and all the way. Like this way, make sure the program knows what is the accurate sequence to compute this recursion. Yeah. This also applies to any other kind of a program, not just recursion. Like all the programs, they are pushed into a stack, like in a sequence that they should be performed. Like no matter what kind of script we write, like even like a for loop, they should be like the computation should be start from the 1 to all the way to the end, right? So all those things are just pushed into a stack so that the program knows which one should be executed at the correct time. So this is a script for this compute factorial program. You can see this is the actual method that do the calculation. It just has some it's just an if-else statement. But one thing to remember, sometimes recursion is elegant, but sometimes it might cause this issue called infinite recursion. For example, this program is very similar to this one, but there's no if conditional statement. So the program doesn't know which at what statement, at what condition it should stop. So it will just return that all the way just -1, like all the way back. Even n equals to 0, it will just return -1, -2 all the way. So it will be go infinitely. So we have to tell the program when to stop. So another very popular or very typical example is this Fibonacci numbers. I'm sure you have already known this number, right? So the first one is 0, second one 1, and the third one is first one plus second one, right? So 2 is 1 plus 1, 3 1 plus 2. So if we summarize this whole thing into this formula, we know we can get these 4 formulas and telling us how we can calculate the Fibonacci numbers. So then all we have to do is just convert these formulas into a recursion if-else statement. So you can see similar to the previous one. Because these two, not different from the previous one. Previous one, only 0 is a base statement, right? But this one, we know for 0 and 1, there is a specific result. So we just need to tell the program that even no matter it's 0 or no matter it's 1, it can return something. And then other than that, it's just this formula. This Fibonacci number is just its previous two numbers plus combined together. So in general, to solve a problem using recursion, I just need to break it into sub-problems. To be honest, it's very difficult sometimes. I mean, this Fibonacci or, I mean, those are just very classic examples. But the good thing is, I think people have already figured out most of the problems that can be done using recursion. So you don't have to design a very good recursion in the future. You can just use, for example, I mean, these two are some good examples, and also for binary search, we will talk later. It's also like specific problems should be done using recursion and will look better. So you just need to memorize them. And of course, recursion always have a conditional statement, and the key is to find out the base statement that can stop recursion, and also, of course, that formula that calls the recursion function. So have you learned binary search previously in 1046? No? Binary search is like, if you want to search something in a list, you just first sort this list from the smallest number to the largest number. And then each time, you just need to search, like compare the number with the middle number in that list. For example, if I want to search 11 from this list, I first compare it with the one in the middle of the list, which is 50. Because 11 is smaller than 50, so I don't need to care about all the numbers larger than 50. I just need to care all the numbers smaller than 50. This kind of way, like each time I will divide the list into two sections. It's kind of binary search. That's what we call it binary search. Again, now the list is shortened to this smaller sub list. Okay, we just compare with the one in the middle, compare it with 10. Because it's larger than 10, we just need to compare all these four numbers that's larger than 10 and smaller than 50. Right. So yeah, binary search, you can see it's a kind of problem that divides this huge problem into sub-problems. Like each time divide the list into two, divide it into two. It's like divide a huge problem into sub-problems recursively. So it's similar, like we said here, like every recursive call reduce the original problem and bring it closer to the base case. So this is a script, like recursive binary search. I will give like explain like this low is the index of the list at the beginning should be 0, and high is the index at the end is like the length -1, right? We just search from the two end of the list and all the way back to the middle to figure out where is that specific number we try to locate. And the mid here is the middle index of the list, which is equals to low plus high divided by 2. So I will give everyone like 5 minutes to think about this. This is a very typical problem that can be solved using recursion. Yeah, this is the list, right? It has the low is a low index and high is a high index. So to fill out two blanks, we just need to figure out how to fill out all these 4 blanks here in this function, in this method, because this method, it has a 4 input number, right? So the first one is always a list. We don't need to care about that because that's the thing we want to search. And the second one is a key, right? That's the number we want to locate. So all we need to do is to figure out what these two are. And you can see here, the first statement is if k is less than least mean, which means if the number we want to locate is in this specific range, it's smaller than the one in the middle. So we will say the first one will be low, and second one actually is be made -1. Yeah, because actually we already compare the middle one with the number. If it's the same, we will return the result, but it's not the same. So we don't need to care about this one anymore. We just need to figure out, I mean, all the number in this lower part. And similarly, if it's not equal and I mean, this else statement, which means the k is larger than the middle number, then it's just made -1, and this one will be high. It's just the two index tell the program which part of the program, I mean, the list you should search. So yeah, you can see it's just we can just tell the program the index, and it will do this for us recursively. We don't have to tell the program like each step what exactly the index is. It will just compute it for us directly. So you might already figure out that recursion is very similar to loop. Actually, if a program can be solved by recursion, you can always convert it into a loop using a for loop or while loop. It's just sometimes if you do it in recursion, it will look nicer. And of course, it's especially in an interview, if a problem can be finished using recursion and you just using a loop, the interviewer will believe that maybe you are not strong enough in this kind of algorithms. So yeah, just I think just memorize these typical questions so that you can be prepared in the future. And also recursion actually need a lot of memory, because before the final computation, everything need to be pushed into the memory stack. Will requires a lot of memory, but yeah, it might also require extra time. But sometimes we don't need to care about that. We have a powerful computer. It's just the screen looks nicer. So let's see a small example. So let's write a recursive method that can convert a decimal number into a binary number. So let's try to finish this method. I will give another 5 minutes for others to think about, then I will write down in the lab. Okay, let's see how we can solve this problem. I will just show it on the screen. So we need to finish this method, right? So if the value equals to something, we return something. This is the base statement. We need to program to stop, and else we do the conversion thing. We know that to convert a number, for example, we want to convert 5 to binary. So the way is we can just first divide it by 2 equals 2. And also we need to calculate the remainder of 2, which is 1. So this 1 will just go all the way here. And then here the divided result is 2. We do the 2 divided by 2 again equals to 1. 2 divided by 2, remainder by 2 is 0. So this 0 will go all the way here. And there's 1 remainder, and 1 divided by 2 is 0. 1 remainder, can anyone still see it? Okay, equals to 1. So this 1 will go all the way here. And this 0 means we can stop. So that this 0 is a key controls that how to stop. So if value equals to 0, we can actually stop and just return a blank space. I mean, not the blank space, just nothing, and the program knows we can stop. Otherwise, we just need to call this method recursively. Specifically, because we only keep the remainder part like each time, right? So we will set the value remainder by 2 here. And the one divided by 2, the result, we will keep it and do the calculation recursively.
Does that value updates after like if it does update or not?
Yeah, it does update. Yeah, yeah. Because at the beginning, it's the original value. And when you call this one, this value already changed. I mean, it's just a number in the, I mean, this one is just a variable to keep the result, right? In the memory, it's just a specific number like 5 or 2 or yeah, go into the program. So that's all about today's lecture. So as I mentioned, we will have tutorial on Thursday. So this is a program. I mean, this is a problem I'm going to explain on Thursday, and then I will give additional 2 program for everyone to practice. Yeah. Thank you.